the preferential discharge of ions in electrolysis, during electrolysis. Now, when we talk about the preferential discharge of ions, what do we really mean? What it really has to do with this is that during electrolysis, electrolysis of any given substance, maybe a salt solution or an acidic solution or even an alkaline solution, we have it that the species involved here, that is the cations and anions, migrate opposite ways. So the cations, usually two cations, migrate to the cathode, and two anions also migrate to the anode. There are the cathode and anode. One of the ion will be discharged preferentially as against the other one. But before such ion is being discharged preferentially at the cathode or at the anode as against the other ion, there are criteria that are considered. So what are these criteria or conditions that are considered before an ion is preferentially discharged as against the other? One of these conditions that are considered are the positions of the ions in the electrochemical series, the concentration of the ion, and of course the type of electrode that is being used. There are electrodes that facilitates or supports, or rather we can say encourages, the discharge of a particular ion instead of another ion that should ordinarily be discharged. So if we use such kind of electrode that loves the discharge of ion B instead of ion A, then the electrode will encourage or facilitate the discharge of ion B. The same also applies to concentration, the second condition. If between ion A and ion B, ion A should be discharged, but the concentration of ion B seems to be more than ion A, then ion B will be discharged. And we have the position of these ions in the electrochemical series, also known as activity series. In the electrochemical series, of course, the very reactive cations or metals are at the top of the series, while the less reactive ones are found below. So the ones that are at the top of the series tend to be very reactive, as we said. So it will always make the ones that are low to be discharged preferentially as compared to the ones that are higher above. Let us take a look at the electrochemical series just to remind ourselves again of the electrochemical series. How is the electrochemical series like? So the electrochemical series is simply drawn this way, and it will be good that students get to know how to draw this electrochemical series. You just practice the electrochemical series and you will surely get there. Okay, so the electrochemical series is simply an array of the cations. So we have potassium ion, which is a positive 1, sodium ion +1, calcium +2, aluminium, magnesium, I beg your pardon, magnesium comes before aluminium, magnesium +2, aluminium +3, we have zinc next +2, and then iron +2. We have tin, though iron also has +3, tin +2. Then we have lead +2, and then hydrogen single plus, copper next. You can see copper is below hydrogen, and then we have mercury. After mercury we have silver, and then we have gold. So this is the cation electrochemical series, and we also have the anions Here we have fluorine, we have the sulfate ion, 2 minus, nitrate ion, single minus, the chloride ion, 1 minus, bromide ion, single minus, the iodide, minus, and the hydroxide ion, single minus. So this is the anion, and if we go this way, that's like this, is increasing preference for discharge, increasing preference for discharge, increasing preference, increasing preference for discharge. Similarly, if we come down this way, it is also increasing preference, increasing preference for discharge, for discharge of the ions. So this is the electrochemical series. It is very important that you should get used to this series, as we'll be making use of them during the course of this class, and also in your subsequent studies in chemistry generally. There are other topics, other areas where you can apply the knowledge of the electrochemical series. It is very, very important. You can even make up a mnemonic in order to remember this series, vividly. So looking at the electrochemical series, one of the factors or conditions that should be considered before we look at the preferential discharge, that is to say, in the discharge of ions, we said that one of the conditions to be considered is the position of the ion in the electrochemical series. So if we have, for example, a solution of sodium chloride in any vessel, and we have electricity passed into such solution for electrolysis to take place. So what we are going to have is, this is sodium chloride and this is water. So it means that sodium chloride is going to dissociate into sodium ion and chloride ion, while water, let me put that very well. So we have chloride ion. Then for water, water is going to dissociate into hydrogen ion and hydroxide ion. Now looking at the cations present here, there are sodium ion and hydrogen ion. So these two migrate to the cathode, while the chloride ion and the hydroxide ion or hydroxide ion migrates to the anode. Now at the cathode, between hydrogen ion and sodium ion, who will be discharged at the cathode and who stays back in the solution? We'll observe that according to the rule, the first rule which we are talking about here, the preferential discharge of ions. So who will be preferentially discharged between sodium and hydrogen? We can see that the distance between sodium and hydrogen is quite a gap. We can see how far sodium is from hydrogen. So that tells us that sodium will stay back in the solution while hydrogen will be discharged at the cathode. So automatically it tells us that hydrogen will be discharged at the cathode. So hydrogen will be discharged at the cathode here. So it comes out, as a matter of fact, this is hydrogen plus, so hydrogen gains electron and then comes out as single hydrogen, and then it can combine with other hydrogen atoms to give us hydrogen gas. So this is what happens at the cathode. Now what about at the anode? What happens at the anode? Looking at chlorine, the chloride ion and the hydroxyl ion. This is chloride ion and that's hydroxyl ion over there. So we can see the distance between them is just not so much as in the case of sodium ion and the hydrogen ion. So what happens between chloride ion and the hydroxide ion? The chloride ion is actually more electronegative, but we can see that the hydroxide ion is least in that series of the anions. The hydroxide ion is least. So since hydroxide ion is least, we said that the ion that is lower in the series will be discharged in preference to the ion that is higher in the series. That is actually the rule. So between chloride ion and hydroxy ion, the hydroxy ion which is least in the series will be discharged in preference to the chloride ion. So as the both of them arrive at the anode, then it means that the hydroxy ion will be discharged while the chloride ion stays back in the solution, but the hydroxy ion will be discharged at the anode, and that is actually what happens. So it becomes neutral. It becomes a neutral species, and since it becomes neutral, it can't stay that way. It has to combine with other hydroxy, and that gives us water plus oxygen atom. Oxygen cannot just stay that way, so the oxygen atom also combines with more oxygen atoms, and what happens is it gives us oxygen gas. So this is actually what happens at the anode. So it is simple. So looking at the position of electrons of the ions in the electrochemical series, what it simply tells us is that the ion that is lower in the series is discharged in preference to the one that is higher in the series, or the one that is more electropositive or more electronegative. So between the cations, the more electropositive ion stays back in the solution, while the least will be discharged, as you can see between sodium and hydrogen. The same also in the anions, the more electronegative stays back in the solution, while the least actually will be discharged in preference to the other one. So this is actually what position the electrochemical series is all about. This is what the position of the ions and the electrochemical series is telling us. So we can see from the display on the screen what that is actually telling us. So having seen what electrochemical series is and an example of electrolysis of a given aqueous solution, that is solution of sodium chloride, let us take an in-depth view of what the position of these ions in the electrochemical series can actually do.